Alrighty, hi everyone. Just a reminder, be sure that you're going ahead and completing these videos and these notes and uploading clear scans of your notes to the correct assignment before the deadline. You will receive points off if you're uploading them late. So be sure to get on it and let me know if there's any issues with links or anything like that. I wanted to do a little bit of review as we start this one. Again, we should have seen some of this in class, but just to make sure our notes are completely clear and completely complete, we're going to go ahead and backtrack just a tiny bit to remind ourselves that we're going to be focusing on two types of statistics. We're going to start our class with descriptive, and then the second part of class will be inferential. As a reminder, descriptive sounds like descript, so like, going in the describe part of statistics where we describe what we see with the data. Inferential sounds like infer, where we go in and we're like, what can we say about what we may not know? What can we infer about something we don't necessarily have in our hands right away? Okay. Now, again, part of what we need to be able to do is really make sure we're clear about the different parts of information that we're given and what's going on. The first part of statistics, the first part of this, gathering and synthesizing information and data is knowing who or what we're gathering from. So we start with the population, which is all elements in a group of interest. Now, again, this is very, very fancy words for saying the group of everything we're interested in. For us, it's always going to start with the word all blank. Okay. Now, a lot of statistics that we see all the time come from, all Allen Hancock students, all people in the United States, all people in the world, all, citizens of Santa Maria, all blank. Now, that doesn't necessarily mean all populations have to be people. We could be talking about all the hairs on Anna's head, all the blank, right? All the cows in San Luis Obispo County, all blank, okay? So all blank is what we're going with for population. It's our group of all things together. Now, we often want to know something about this group. We want to know the percentage of cows that are over the age of 5 years old. We want to know the average age of Allen Hancock students. We want to know these specific things about the population, and we call these things we want to know parameter. So it is a number characteristic of the population. Again, I may have mentioned in class. If not, be sure to remind me. The parameters that we often see come in the forms of like percentages or averages or a little crazy, we don't see them as much, standard deviations or medians or these other sort of percentiles, these number things that we're going to be talking about in this class. Okay. Now, we can't usually get to the entire population. It is really hard to get you guys to answer your emails, so getting all Allen Hancock students is really tricky. We take a sample, which we hope is a subgroup of our population with the same characteristics, including but not limited to number characteristics, with the same characteristics. Okay, the same characteristics. Now, okay, so we find this group, we find this subgroup that we're going to be able to hopefully find some information about. Okay, and that information is often going to be synthesized down into a statistic. So remember, when it comes to statistics, we're talking about basketball and basketball, the game of basketball, and the actual sphere we use to play the game. So the game of basketball, the game of statistics is like this whole process, including all these different vocab words. Okay. Now, the ball part, the actual sphere part of statistics is what we're going to talk about now, which is a number characteristic of the sample. And you'll notice that it is the exact same wording as parameter, except it comes from a different place. It comes from the sample versus the population. And again, it's really nice. They actually organize this well for us because parameter goes to population, those P's stay together, and statistic goes to sample, those S's stay together. So statistic of the sample hopefully matches the parameter of the population. Okay, if we've got a good sample, it will. Now, data is the things, the information, the pieces of particular info that we get from our sample to actually calculate our statistic. So this is the individual information from our sample, okay? Usually in the form of some list or organization, which we're going to be talking about here in chapters 1 and 2. We're going to be describing a lot of data, okay? Now, if we are so lucky to be able to actually get data from the entire population, not just a sample, the entire population, we call that taking a census. The data for an entire population. Okay, it's the information from every element of the population. Okay, again, these should all be reviewed, but make sure they're clear for you. I know I've used some rather technical terms here, so please come by office hours or reach out to the tutor if you have any questions about these. We are now going to use these. Okay, now, how are we going to use these? What are we going to do about it? Check this out. We're going to use a question. We're going to use a question and ask everybody in our sample, every element, every single individual, for each individual of the sample, or if we're able to take a census, the population, or population is called the variable or variables. We might need a few. We might need to know more information. Okay, variables. Now, if you've taken a different math class before, you might be thinking X and Y. This is not X and Y land in the same sense that we have done for a lot of algebra stuff. However, it is related. So what's kind of cool about this, the official name of a variable is a characteristic of interest for each individual in a population is a variable. And I'm going to write it like this because we might need more than just one. Okay, we tend to use capital letters like X and Y. Aha, should sound kind of familiar. Related, but not exactly the same. Okay, they may be words or numbers. Okay, questions that are answered with words or numbers. Okay, and the actual values, the actual information we receive back, values or info, we collect from our sample are called the datum. Datum means one, and together they make data. Okay, and maybe again, words or numbers have official stats names. That's called qualitative or quantitative. More information on that shortly. Okay, so again, words, qualitative, then there are numbers, which are quantitative. Okay, so let's see. I'm going to come up with a very random example. We are going to be doing some of these in class, so don't worry, we're going to go through more. And I need to think of a variable. Okay, and the first thing I need to do is I need to decide what group am I going to be thinking of a variable for. So the population I want to do, let's say I go extra nerdy and I say my population is all Pokemon. All Pokemon. I think I'm spelling it wrong, but that's okay. You guys know what I'm talking about. Okay, all Pokemon. That's my population, all Pokemon. And X again is a variable, is a question that I'm going to ask of a sample of Pokemon. So I have my population. I would take a sample, which would be a group of Pokemon. Now, what do I want to know about these Pokemon? There's lots of different things I could ask about them. I want to go really, really simple here. Okay. And I'm going to let X be, how about, does your name start with a B? Okay. That's all I'm going to do. Does your name start with B? Okay, does your name start with B? Really, I mean, Bulbasaur, yes. Pikachu, no. Okay, really easy, straightforward. All right, so here's my question. Does your name start with B? Now you'll notice that this is actually a variable we could use for tons of different populations. Okay, we're just happening to use it for all Pokemon right now. Okay, does your name start with B? Let's think about the answers to that. And my answers are going to be words or numbers. I think my answers are going to be words, right? Answers, words. So, ladies and gentlemen, qualitative. That's a qualitative variable for these Pokemon. Okay. Now, I would love to write out my data and statistic. I would need to go in and take a group of Pokemon. I'm not going to do that right now, but we are going to do some in class. Okay. So don't worry about that too much. Now, a statistic, let's just talk about that. Again, data would be my list of yeses and nos, my list of answers. List of answers. And a statistic would be something number-wise that I would calculate from that list. Like maybe the percentage of yes answers. Okay? Something I could calculate. A percentage is a number that I would get out of this. Okay? Now, would we all get the same data? Would we all get the same data? Yes or no? It really depends on the sample. Would we all get the same data? Nope. Depends on the sample. Once again, ladies and gentlemen, we will actually be gathering some data in class. Hopefully that will make more sense. So don't worry about this too much. We'll come back. Okay, let's check out another possible example. Okay, let's say we want to know the average or mean amount of money spent eating out each week by Hancock students. We randomly survey 100 students who attend Hancock. 3 of the students said they spent 15, 25, and 50 respectively. So what you're going to notice here is I'm actually going to start underlining and highlighting some key information here to help me answer the questions below. I take a quick peek and I need to know things about population and sample and parameter. I've actually already started underlining some keywords for myself. I have average and money spent by Hancock students, survey 100. 3 of them gave us this information. Okay, I think I've got most of the information here. The population. What group am I interested in? Be careful. A lot of students are going to say, oh, you're interested in money. And that's not actually the thing I'm interested in. I'm actually interested in the population, all AHC students. Because it's average amount of money, that's a number characteristic, but of what group? Of Allen Hancock students. Okay, the sample is the 100 surveyed students. Surveyed students. The parameter, again, that number thing I want to know is actually listed up at the beginning. The average money spent eating out each week. You could actually just say average money. That would also be a perfectly acceptable answer in this situation. I wanted to be very specific about what number thing we wanna know about. Now the statistic. The statistic. Now that's gonna start just like parameters. So I'm gonna say average money spent eating out. Now, what's the difference? Is it going to be the exact same answer here? Well, I hope not. The parameter is of my population of all AHC students. And the statistic will be of my 100 surveyed, aka sample surveyed students. Same basic idea, same basic thing, different groups. Okay. Now the variable is tricky because the variable is the question I would use to get my data. What do I need to ask the students in my sample? Well, I think I need to ask how much do you spend eating out? Let's say, like, I don't want to say each week because it's going to change each week, right? How much do you spend eating out in I'm going to say typical week? There are many possible answers here. You could say, how much did you spend eating out last week? How much do you think you'll spend eating out this week? How much do you plan to spend eating out each week? Something like that. Okay. The data. Now, the data would be my answers here. And I actually do have 3 answers. We have $15, $25, and $50. And then we should theoretically have 97 more answers. We don't have them written down up above, and that is okay. All right. So what we've done is we've taken this specific scenario. We got our clear, I hope, ideas about what population we need. Then we want to know what we're surveying about and how to get there. Okay. If you have questions, be sure to check with office hours or double check with the tutor or the math center. We'd love to help you figure out what's going on here. Okay, now I did mention earlier that we were going to check into those different types of data. So let's go ahead, let's head into section 1.2 and let's talk about data sampling and variation in data. Okay. So it turns out that data can actually be organized into 2 clear groups that we've already gotten before. We have our word information and our number information. So our qualitative and quantitative. Qualitative and quantitative are the 2 types of data. Again, remind yourself, this is like our words. It is often called categorical, but I would like you to be careful because categorical in some textbooks means something even more specific. Quantitative, which is our numbers, does have to be a specific type of number that is measuring something or counting something. It can't just be a willy-nilly number. And we'll see a few examples of why things that look like numbers are actually in the qualitative rather than the quantitative. Now, quantitative itself also has 2 groups. It also has 2 groups. Now, these are called discrete and continuous. Discrete numbers are only when certain numbers make sense or are possible. If I were to ask you how many siblings you have, you could tell me 2 or 3 or 4, but you could not tell me 2.8679. That just, it wouldn't make sense. Okay, specific numbers only versus continuous. Continuous is where any number between a start and an end would make sense. So if I asked you what percentage of people in the US have green eyes, you could definitely tell me 20.63925%. That would be perfectly reasonable. So any number with as many decimals as you want, as many decimals as needed, from a start to finish. From start to finish. We will be looking at a couple of different examples in class about discrete versus continuous numbers. Okay. Below, I have a couple of examples, and what we're going to do is we are going to determine whether the data is qualitative or quantitative. If it is quantitative, what kind of quantitative it is. So we're going to be as specific as we can. All right. So here we have monthly salaries of employees at Spencer's Market. Monthly salaries. Now, salaries come in all shapes and sizes. They're pretty much from like a bottom to a top. And because we do go out a few decimal places, we're going to go with quantitative, measuring how much money you're getting. Continuous. We can get all the way down to a cent. Holy Toledo, that's down pretty far. Okay. But a social security number at an accounting firm. A social security number is a number, but does it measure anything about the person? No, it puts it into a person into a category, believe it or not. So since it's a categorical answer, or like a what kind of group do you fit an answer? That would be a qualitative. Okay, qualitative. Okay. The age of everyone in my family. Now, age is really, really tricky, particularly because we almost never answer with anything other than years unless they're babies, and we might say it in like weeks or months. Okay. Because we round to the nearest year like that, I'm actually going to call it quantitative discrete. But if you remind me in class, I can actually show you a really cool example of why age is, if you live in like physics land, very technically quantitative continuous. Okay, remind me in class. Now, if we're talking about zip codes for people living in California, we're not all going to have the same zip code, but does a zip code measure something? Well, no, it's just a category for where you live. So that one's also going to be qualitative. Believe it or not. Crazy, right? So all four of these things may look like number answers, but we can see two of them are quantitative, but the two other ones are actually qualitative because of the categorical nature of their answers. Okay. Now, different ways to organize and display data. So once we get all these answers, once we get these lists of things, we're actually going to be putting them into very specific displays. We're going to let technology do the heavy lifting here. So I'm going to be really, really quick, really, really vague about some of these different parts of displaying data. So don't worry, we will be doing just a tiny bit in class, but I'm actually going to be more interested in reading displays than in making them. So just bear with me as we make it through this next bit. Okay. The main thing that I want you to be really careful with when dealing with a display is they need to have a title, particularly a title with population and variable information. Most of the time, we're going to get the population in there really, really clearly. The variable will be a little bit trickier. Okay. Sometimes we may even find graphics that have multiple variables in them. So it will actually leave the variable heavy lifting to the labels that it includes lower down. Okay. I just wanted to use this space right here, even though we're going to go very deep into chapter 2, to write a couple of key ones that I hope you've seen before. If you have not, it might be worth heading to office hours or even going onto YouTube to double check some of these displays. The real popular ones are pie charts, which I hope you've seen before. If you haven't, please, please, please come by and we can definitely talk about pie charts. Bar charts. Bar charts, also very particular. Now, there's kind of a specific like subcategory or similar type of chart to a bar chart. Bar charts are almost always for qualitative unless they are made into what we call a histogram. And a histogram is a special bar chart for quantitative data. We shall talk about both types. Quantitative. Okay. Are these the only 3 types? No, not even a little bit. There are so many. We're going to talk about more in chapter 2. So don't worry. We're going to get there. Okay. So more in chapter 2. Okay. Now, let's actually talk for a few minutes about how we're going to deal with samples. Because again, samples are these like subgroups. Remind ourselves, recall, sample. Wow, I can spell sample. Sample, also recall, is a subgroup of the population. But ideally a subgroup with the same characteristics. With the same characteristics. So again, gathering information about an entire population often costs too much or is virtually impossible. Instead, we use a sample of the population, and a sample should have the same characteristics. It should have the same characteristics. Okay. Now, what we're going to do is we're going to talk about some very clear methods to gathering a good sample. I'm actually going to be a little bit vague about these in this video because we're going to have a great activity in class. So please make sure you bring these notes, you get ready for when we do our activity in class. Okay, so here's the first one. The first one is technically the best one to use, but is also technically the most hardest to use. Okay, most hard to use. There we go. It's called simple random sampling, even though there's very little that's simple about it. It's called simple random because it's fairly straightforward, which it is. The setup is very, very straightforward, where you're actually going to give each member of the population a number. With Allen Hancock students, that's already been done. You guys have H numbers. But if we're talking about, say, all Pokemon, that one's a little bit trickier. We've got to figure out a way to give every single individual Pokemon a number. Okay? Then we're going to use a random number generator to get a set of labels, to get a set of numbers that we are going to go out and sample. And then you're going to go to those labels and you're going to sample. So the selected labels, build your sample. Now, again, with Allen Hancock students, if I look up an H number, I could find an email and try to email you. Hopefully you'll answer. But with Pokemon, maybe I can actually number all the different Pokemon, but then I use my random number generator. I have to go figure out which ones I'm asking, and that can be really, really tricky. Think also, or imagine also, if you wanted to say number all trees in a national park. Holy Toledo. Like, how would you even begin to number that? That would be really nuts. So even though it's called simple random sampling, it's often not simple or easily done. Okay? But it is the best for true randomness. That's the thing we're after here. We're really hoping for random to help us with this. Okay. Next is called stratified sampling. And stratified sampling is about putting the population into groups called strata and then taking a proportionate number from each of the groups or each of the strata. That sounds rather confusing until you remember it by the cake bite method. And the cake bite method is actually really great because in a piece of cake, if somebody brings you, say, a piece of cake, you have, let's see, let's draw myself a piece of cake. Here is my piece of cake. And we know we have our bottom layer of cake, right? We got some nice sponge cake going on here. And then we have a middle layer. It's usually pretty thin of some sort of filling. Then we get another layer of cake. And on top, we have our frosting. Right. Okay. Now, if you're not a complete monster, you're going to go ahead. You're going to take your fork. Let's see. I'm going to draw a little fork right here. fork, and you're gonna take it straight down through that piece of cake, and you're gonna get a little bit of every single layer. But you can see if the filling layer is thinner than the cake, you're gonna get more cake, right? That's because you're taking a proportionate amount, okay? You're taking the same percentage from each layer, okay? I think this will make more sense again during our activity. All right, so that's called stratified sampling. You take some from each of these groups. Now, setting up the groups, again, not necessarily simple or easy, and we'll talk about different ways to do this as well. Okay, then we have cluster sampling. And in cluster sampling, you're actually going to start the same way as stratified sampling. You're going to divide into clusters or groups, and then you're going to randomly take some from one or a few clusters, but not all the clusters. Okay, I know it says all the members of these clusters get sampled. That's not all actually true. Okay, you're going to try to get most of them, but you take a whole bunch of one or two clusters, but not every cluster. Okay, one or two clusters. One or two clusters. I have some friends in the wine business. It reminds me of when they go through the vines and they'll take a whole cluster out, okay? But they leave all the other clusters, all the other groups up on there, okay? Now, we also have something called systematic sampling. Systematic sampling is where you start with all the members lined up. Start with all the population lined up. Then you randomly select a starting point and take every nth piece of data. This one's really great, again, if you already have some sort of lineup, like maybe I have a lineup of all episodes of Simpsons ever made. I have a huge long line, all listed out, all ready to go. Okay. And then I start at a specific spot and then I take the same jump every time. So maybe I start with the 15th episode and then I jump by 5s. So I take the 15th, the 20th, the 25th, the 30th, the 35th, the 40th, the 45th, etc., all the way down. Okay? Systematic sampling. The last one, which often happens, but is definitely not our favorite, is called convenience. Convenience sampling. Convenience sampling. And that word, man, convenience, is not convenient. Pun. Okay. A type of sampling, it's not random and involves using results that are readily available, meaning go out and get whatever data is fastest, easiest, cheapest. Get data by the fastest, easiest, cheapest method is convenience sampling. Okay. All right. Now, please note, even if you take a great sample, nothing is perfect because nothing is ever perfectly the same as anything else. So there is going to be error due to natural variation, meaning the things in your sample should just be different. Okay, the Pokemon should just be different. The Allen Hancock students should just be different. Okay, or sample bias. Usually a mixture of both. Usually both. One more time. I went pretty fast and was pretty light on each of these. We'll be talking more about them in class. Please make sure you bring your notes with you and you get ready. We will have a quiz right when we start class as per usual. And I look forward to giving you guys some more information about these different methods. Looking forward to seeing you in class, and don't forget to finish the next video as soon as you can. Have a great day.